What's going on, everyone? We are back with another JS drop. It's one of my favorite segments that we do here at this Labs. And to be honest, the guest today is one of my favorite people in the world of tech. It's someone that I've known now for what is it, over 5 years, give or take.
Yeah.
He to me is a very big deal, as he is to probably other people as well. And so today's episode in particular is going to be a JS drop in regards to AI with the Vercel AI SDK. And for those that aren't familiar, I'm joined with Jesse Hall, aka CodeSTACKr, very popular YouTuber. He is a phenomenal educator, conference speaker. What else are you involved with, Jesse? He's active in social media. And on top of that, he is the staff developer advocate at MongoDB. And so, Jesse, how's everything going with you, man?
It's going great. Thank you for the intro. Thanks for having me. Yeah, that's I'm not that great. I just love to teach developers. That's the main thing that I do. I create content that I hope will help developers.
Hey, I like it. All right. So without further ado, Jesse, the floor is yours. Look forward to your JS drop.
So we are going to talk about AI in JavaScript, right? But AI in 2 lines of code. How about that? AI in 2 lines of code. So we're going to talk about some basic, chat, and then go off into some agentic stuff as well. So covering, the basics all the way to the more advanced as well. But here's those 2 lines of code. Like really, if you just look at this, we're using a hook, use chat, and then we're just basically plopping that into our form. So this is basically it. So, I mean, when I do this in person, I say talks over, okay, and then I walk off the stage and then I come back and yeah, okay, just kidding. No, but seriously, it is almost this simple. So we already introduced myself. So here's a question for everybody. Are you an AI engineer? Do you think you could be an AI engineer? Most people they say no because they don't know anything about machine learning. They don't know anything about they don't know Python. They don't know math, linear algebra, etc. And maybe they don't even have a computer science degree. But here's the thing: is you actually can be an AI engineer. And because I don't have a CS degree. I don't know Python very well. I don't know how to train ML models. I don't know anything about that area of computer science at all. But I consider myself an AI engineer. And we're going to talk about why that is and why you can be as well. And so here's a quote from Swyx, Sean Wang. If you don't know who Sean Wang is, go Google The Rise of the AI Engineer. And so he says here that a wide range of AI tasks that used to take 5 years and a research team to accomplish now just require API docs and a spare afternoon. And isn't that the case? Have you, especially if you use like Windsurf or Cursor or what's the other one, Copilot, you just put in your API docs and let it go, right? It takes no time to build things these days. So he is very accurate in that, and he's not the only one saying these things. Andre Karpathy, formerly from Tesla and OpenAI, focus on the last bit here. One can be quite successful in this role. He's talking about the AI engineer without ever training anything. So he says that there's going to be more AI engineers than there are ML engineers in the future. And think about that. We're talking about AI is basically an API, right? So if you think about that, how many engineers does it take to build the API endpoint, right? Not very many, but how many developers consume that API endpoint? Could be millions, right? So in that, if we think about it in that lens, then we can see how there's going to be so many more AI engineers. And so this is another image that Swyx came up with here, and we can see that API division in the middle, and it's a dotted line, and we'll talk a little bit more about that dotted line. But on the left side, we've got data, the ML researchers, the engineers, and on the right side, we've got AI engineers, full stack engineers, people, developers that are building things with the models that the ML engineers are creating, right? And now this is not a black and white situation here. There are some things that can bleed in between these two sides. That's why there's a dotted line there. But in the very most simple of terms, AI is just an API. And so, there's different types of AI. There's rule-based AI. You could think of this like the video games that you played growing up, like Super Mario Brothers. For me, it was Galaga and Pac-Man. Like these are things that engineers programmed them to do. And so that's like a very rudimentary role-based AI. Then we have predictive AI. You're writing in Google Docs, and it tries to predict your next word. In your IDE, you're typing code, and it's predicting, and you're just hitting tab, right? That's predictive AI. And then there's generative AI. Of course, this is the hype. Everything is moving towards generative AI. Again, in the IDE, generating images, etc. Right? But there's some caveats here because there's limitations to these generative AIs, these LLMs. These models hallucinate. They can be very confident in their hallucinations. They have no concept of right and wrong. They have no concept of truth and lie. They just know what they've consumed, and they can hallucinate. So we have to fix that. They also have limitations to their context windows. Many of these models, they have very, very large context windows, but no matter which model you're using, they all have a limit. They all have a cutoff. So how do we work with that? And then the knowledge cutoff as well. So they all have been trained to up to a specific date and time, and they only know what they've been trained on. And so there's one thing that solves many or all of these problems, and that is RAG. And you've probably heard of RAG before, retrieval augmented generation. If you haven't, this is going to be the most simplest explanation that you've ever heard. There's talks that just specifically focus on this for the entire talk, but it is actually a very simple way of going about solving these problems with these LLM models. And so first off, we retrieve up-to-date information from some authoritative data source. And then we augment our prompt with that information. We add that into the context that we're giving the LLM. And then we let the AI generate a response based on that extra context. This is all RAG is. Very simple. Retrieve, augment, and then generate. So the thing that makes all of this work is vector embeddings. And so, what these can be derived from text, from images, from audio, video, etc. And these are the kind of basis of how we get this extra context. And so when we create vector embeddings from these various sources, they are translated into an array of numbers. And these aren't just any numbers. These are coordinates in a multidimensional space. And so if you think about plotting out like a 3D vector graph, you have an x-axis, you have a y-axis, and you have a z-axis. Well, in this context, we're talking about many, many more dimensions than just 3 dimensions. So if we take a quick brown fox, for instance, this translates into an array of numbers, and a common amount of numbers is 1,536. So we're not talking about 3 dimensions, we're talking about 1,536 dimensions. So you can imagine how much more data can be stored in this type of multidimensional space. Now, a caveat here, a side note, is when it comes to vector embeddings or the amount of dimensions, less is more. And that can be a whole nother talk. So we're not going to really get into that. Just put that in the back of your mind. Less is more when it comes to the amount of dimensions that you want to choose. So think about this way. So we are taking these let's text, for instance, and we're translating it into this multidimensional space. We're plotting points in this multidimensional space. So if I take cat, dog, pet, animal, etc., those should all be clustered in a specific area in this space. Car, train, bus, etc. That should be clustered together over here, etc. Right? And so what is the purpose in doing all of this, plotting all of these things? This is how we gain that extra context through something called vector search. So when we ask the LLM something that it doesn't know, it can then take our question, put it into, embed it as well, put it into this vector space, and then find the closest answers to that question based on this, and then retrieve that, bring that extra context back into the prompt for the LLM to answer. So that's kind of how all of that works. And how all of these calculations are made and all this on the back end, I have no idea. This is where I stop. So like I said, I'm not an ML engineer. I'm an AI engineer. I know how to use these tools that I'm given, and I know that they work. I don't know exactly how they work, but I just know that it's going to return me the information that I want to augment my question and my context and get the extra get the correct answer back. So I do have some demos that I want to actually show that show exactly how easy this is to do using the Vercel AI SDK. So if we talk about a text generation, is the most simple way of using generative AI. And so we put a prompt in here. Let's say, what is the capital, if I could spell capital of Texas. I live in Texas, by the way. So let's generate that text. So it says the capital of Texas is Austin. The LLM model knew the answer to this, so it was no problem. Here's the answer, gives us some token information, etc. But how do you actually implement this into your application? So let's look at the code. Let's go to the back end first. I like to start in the back end. So we are going to use the OpenAI from the AI SDK. And then we are using generate text from AI. Now, just side note here, like how cool is this that Vercel got AI from the NPM package? That's pretty crazy. Anyway, so we're using AI. This is the Vercel AI SDK, generate text. So the cool thing down here is we're getting the request body, but here's the easy part, that normally is hard. So generate text, and just we're passing it which model we want to use, the prompt, and then the rest of this is optional. You can tell it temperature, max tokens, etc. But we are just using this generate text and then returning that. This is just a few lines of code here that would normally we would normally have to write much more code to generate this response. And then on the front end, what's amazing is we are just using a fetch, just a standard fetch to this API endpoint. Again, AI is just an API. We can just fetch from this generate and get the response from our prompt. Now, generating is one thing. You notice that when you generate, you click the button and then you might have to wait a few seconds and then it comes in. So even harder to implement is streaming text. So here, let's do something a little bit longer. Let's say let's see. Tracy's not here, so let's do something about this. So write a short story about how much Tracy loves whiskey. Let's see what this does. So when I hit generate text, you'll notice here that it's streaming the response in. So I have no idea what it's writing here. It's probably something hilarious. Maybe we can read this later. But it's streaming this response in instead of us having to wait several seconds for everything to finish and then it coming in, right? This is much harder to implement than just the generate text. But let's see how hard it actually is with the Vercel AI SDK. Let's start with the back end again. So on the back end, again, we're using OpenAI from the AI SDK. And this time we're using stream text from AI. So again, we're getting our body from our request. And then down here, we are using stream text. We're passing it the model, the prompt, etc. And then we're just returning this stream to a data stream response. That's it. Now think about streaming. You have to keep the client side and the server side connected during that entire stream. You have to make sure that it doesn't disconnect, right? And so there's a lot of boilerplate code that you would otherwise have to write. And so this is why it's so great. The Vercel AI SDK is so great at making these things so super simple. On the front end, we're just using another hook from the AI SDK, use completion. And so use completion comes with several methods. We've got the completion, where our input, handle input change, handle submit, is loading an error. There's some others as well that can be brought in. as needed. And then we just tell it which AI or which API to use. And so we have these things. Again, this is just a hook that we're pulling in from the AI SDK, and we have these methods that we can now plug into the rest of our markup. So we have our form here, and we just plug everything in here. So on submit, we have handle submit from the AI SDK. We have our input from the AI SDK. Handle input change, again, is loading. We've got our error down here. All this is coming from that use completion hook from the AI SDK. All of these things we would have to write on our own. So this was, again, what helps us, and the AI SDK makes these things so simple. So moving on from this, streaming text, simple example, let's look at text summarizer. This is another simple example, but it's so similar. So we've got some example text here. What is this long explanation of the MongoDB Atlas vector search and how it works, right? So let's summarize this text, and we'll see this nice short summary of what we have up here, right? Let's look at the code for this. Again, let's go to the back end. The front end is actually exactly the same as our text streaming example. We're using the use completion hook. But the back end, the only difference, again, we're using stream text from AI. And the only difference here is that we are adding a little bit of extra context here. We're doing a little bit of prompt engineering, and we're saying summarize the following text in a concise, informative manner. This is the only difference between this example and the streaming, the text streaming example. So we're adding this extra prompt. This can actually bring in some security issues where there's something called prompt injection, where someone might actually in their prompt here say, forget everything that I said before, do this other thing. And this could be malicious. And so there is this thing called system prompts.
We'll be back to the episode in a second, but first I'd like to acknowledge the team behind the channel, you out of them, through strategic partnerships, trainings, and other software engineering services. Check us out at ai.this.co. Thanks, now back to the video.
So system prompts in the Vercel AI SDK is a more secure way of telling the AI, the LLM model, what you want it to do. And so this is a fun example here. In our system prompt, we're going to say, you are a pirate. Always respond in a pirate dialect and use nautical analogies. And then here's our question. What are the 3 largest countries by land area? So we're going to generate both responses, one without the system prompt and one with it. So let's go ahead and generate. And we see here, this is just the facts. It's just giving you the facts here, the default behavior. And then with the system prompt, our matey seeking the largest, exactly. I'm not going to read the whole thing, and I'm not very good at pirate voices, but you can see here how we can use system prompts to direct the LLM, these models, to do the things that we want them to do, right? And so what does that look like? So if we go over to the code and we go over to the back end, we can see here that we have different roles here. We've got system, assistant, and the user. And then the only difference here is that we are passing in the actual messages with the system prompt. And so there's the different roles that we can then add to the Vercel AI SDK responses. So moving on from system prompts, we have chat history. So one thing is, when you're chatting with some of these chatbots, a lot of times you'll go through and they will forget. They'll forget things, especially if you refresh the page. So let's go in here and say, what is my favorite color? And of course, the AI is not going to know what my favorite color is, right? So it's asking me, what is your favorite color? So I'll say blue. And okay, so now I can say, what is my fave color? And it should say it's blue, right? So it remembers because it has the context of this conversation. But if I refresh the page and then I say, what is my fave color, it's not going to know because I've refreshed the page and it forgot. So if we look over here, it did remember until I refreshed the page. So there's a very basic memory built into the Vercel AI SDK, but it is only in session, right? So if we look at this new use chat hook from the Vercel AI SDK, which we're using here for this example, we can see we're starting with two initial messages. We have our system prompt, you're a helpful AI assistant, and then the assistant message that's saying, hello, how can I help you? And then if we look here at the actual hook implementation, use chat, we're getting some of the same things that we were getting from the use completion hook, handle submit, handle input, etc. But we're also getting messages and set messages. So this is basically a use state hook as well, built into this use chat hook. So messages and set messages. And of course, with any React application, you use a use state hook. You refresh the page, that state gets deleted, right? So that this is expected, right? But we have this in-memory messages array built into the Vercel AI SDK. So how can we implement some memory persistence? Well, we could use something like MongoDB to implement this persistence. So let's start a new conversation and let's say, what is the Vercel AI SDK? And it's going to, give us what it knows about the Vercel AI SDK. And then we can have multiple conversations. Let's start a new chat and let's just say hi. And now we've got multiple chats and we can go back and forth between these chats. It has remembered. So if I had told it something here, it would remember it, etc. And the only difference here is that these are not being saved just in memory, but they're actually being persisted through MongoDB as its memory provider. So looking at the code for this, again, on the front end, using use chat, nothing really different here as far as the chat itself, except that we're implementing some extra things here using server actions. So we have these server actions to create a chat, save a chat, load a chat, list, and delete chat. And then basically we're just handling these at different phases. So in our use chat hook here, there's an on finish. So on finish, of course, we want to save our chat messages. We've got some use effects here to fetch our messages, to list our chats, create chats, etc. So a lot of this is being handled on the front end, but it's actually being executed. So we can go past the JS markup, nothing much there. It's actually being executed here in the server actions. So server actions, again, in Next.js, they're pretty cool. They run strictly on the server side, so you don't have to worry about any secrets getting leaked or anything like that. But we are just basically implementing same as like a Node.js application, connecting to our MongoDB instance, defining the database, the collection, etc., and then just creating each of these functions to create a chat. So create a chat is just going to insert those messages and then save and load, etc. All of these are defined here in our server actions. And then the API endpoint is very simple, actually. We're using stream text, and then we are just grabbing all of these messages, the system message and the regular messages, etc., from whatever the front end sends it. So this allows us to now persist our memory. Refreshing the page is not going to affect anything. We can also, if we go back into the demo, you see that we refresh the page. They're still here. Our messages are still here. We can delete messages, etc. So another cool thing about the AI SDK is structured output. Now, if you've ever tried to get structured output from an LLM, it's become easier, but it in the past has been extremely difficult. But the Vercel AI SDK, again, makes this super simple. So we have a product description here. And so let's go ahead and extract this and see what it does. So it takes this product description, this plain text, and it separates it and returns a JSON object with the name, the price, category, rating, whether it's in stock or not, and all of its features here. And so this is if you're trying to take plain text and convert it into JSON, you can imagine that would be pretty difficult to do. So let's take a look at the code and see how it does this. So on the front end, we're using another hook from the Vercel AI SDK, use object. And so use object has the object, submit is loading, error, etc., telling it which API endpoint to use. And so the magic here is on the back end, where it is experimental right now, but experimental generate object from the Vercel AI SDK. And then the first thing that we do is we define this schema using Zod. So we're telling the generate object method from Vercel exactly what we're looking for. So we have our name, price, category, features, in stock, and rating using Zod. And then we're simply just using that generate object method here, passing it again the model, the prompt, and the new thing here is the schema. So we're telling it this is what you need to return. And then again, the Vercel AI SDK handles all of this on the back end. So if for some reason the LLM responds with something that does not match this, it's going to automatically retry. It's going to do all of the extra things that you would have to do normally for you. So again, making it so super simple. And then on the API route, again, very easy. Again, using Zod here, and then the prompt. So tying all of this together, we can look at some tools. So tools are a way to take various different, I guess, API endpoints. They could be very different things that you want the AI to do for you, and kind of package them into these different tools that you could then put into like a toolbox of sorts, right? And you can use various tools as needed. So here, let's look at a basic example. We're going to ask it, what is the weather in New York? And then also, can you calculate 2003 divided by 7? So that's two totally separate things. Let's run this, and we'll see that it is going to, or it lists here what the user asked, and then the AI's response. The current weather and the additional result of the calculation is 289. So it replied with the correct information, but here's what it actually did on the back end. So it called a tool called getWeather, and it got the weather, and then it returned that weather results. And then it called another tool called calculator, and it said to calculate this expression, and then the calculator returned those results. And so then it returned the actual the final text result response. So how does that work? Let's go look at the back end here. So again, on the front end, we are using use chat, calling it from this API endpoint, passing in our body, and then the extra response here is just extra stuff that we do after each tool. But the magic here is on the back end. So we're using generate text and tool from AI. So tool is how we define these different various tools. So we define our get weather tool here as a tool. We describe it. And again, we're using Zod here to specify these parameters that we're looking for, location and then unit, whether it's Celsius or Fahrenheit. And we're saying the default is Celsius. That's another side thing we could talk about. Should we all just convert to metric or not? Yeah. And then execute. Here's what it is actually going to do. So the weather tool is going to do this. So this is the function that it will return, get the temperature, conditions, and location. Here's the other tool, calculator. So this is described as a tool, and then our parameters will be the expression, and then execute is going to be the evaluation of that expression. So we can then include these tools in our generate text. So we give it our model, our messages, and then our tools. And we also give it a max steps. And this is important so that we don't have an infinite loop. If for some reason it wants to just continue calling tools, we give it a max so that it stops at some point. And then when it's done, just return what you have. And so that is our kind of a first step into agentic applications. So agentic applications allow you to use these various tools and allow the LLM to then decide which tool that it wants to use. And so one of these, we'll get to the actual agentic example in just a minute. One of these tools could be RAG. So we talked about RAG before. So here is an implementation of retrieval augmented generation using MongoDB. So in this, we have set up some vector indexes already, and we've seeded the database with some documents, 5 documents to be exact. And we can ask it questions about MongoDB, vector search, RAG, or related topics, and it should return up-to-date information about those. So let's ask you, what is the Vercel AI SDK? And we asked the other model this in one of these others. I think it was under chat history, and it gave us a long response, and it said, this is all that I know, because I think at the training time, Vercel AI SDK might have just been released, so it didn't know a whole lot. And so in this response, it's a little more succinct, but this is actually what we've given it on the back end to tell us, because it's pulling directly from these 5 documents when I ask a question. So let's look at how that is implemented. So let's go to so we've got the front end implementation, we've got some server actions, and then the API route. So let's go to okay, so let's look at the server actions first. So on the server side, we're using this to set up our database first and make sure that we have our indexes and our seed data, etc. We're using Voyage API to create the embeddings. There's many different AI models that you can use to create embeddings, etc. But we're using Voyage AI here. And then we are setting up our vector indexes, seeding our documents. And this is what I wanted to show you here, the documents. So we have 5 total documents, but basically we're providing it this information, this content that we want to add in. This is generally proprietary content, something that the LLM would never know how to answer. And so we give it this context, and then this content here gets translated into embeddings and then saved to the database. So during this part right here, generate embeddings, where we are then using, again, Voyage AI to turn that text into an embedding and then save it into the database. And then this is the magic part here, find embeddings. So whenever we ask a question on the front end, it calls this every single time to make sure that it's retrieving the most up-to-date information. So first, it's creating an embedding from the user's query. So because we have to put the user's query in that same multidimensional space as our proprietary information embeddings. We tell it the collection, and then we actually retrieve these documents. So collection.aggregate, and we're using, again, vector search here to retrieve those relevant documents. And then we just send those documents back. So on the front end, we're using use chat again, and then we are pulling in our vector index and example documents just to make sure that those are set up. We're running those, and we're telling it that you're a helpful assistant, etc. We have our system message here. On the API route, this is where we are implementing the find relevant documents. So we call the API route from the front end. On the back end, we're using stream text. So let's go down to our stream text here. Relevant documents is going to come from the user's message, and then here is our stream text. So again, we're just sending, this time, instead of just the message, we're sending the enhanced system message, which adds that extra information. So if we come up here to the enhanced system message, we'll find that we're bringing in our relevant documents, but then we're adding that into our enhanced system message here. So we have our system message and then adding that extra context. So all of that gets sent to just the regular stream text from the Vercel AI SDK and then sent back to the front end. So we're just injecting this extra context where we're intercepting the user's message and then injecting this extra information, sending it on to the LLM, and then retrieving that response back. So tying this all together, let's go into our last example here, where we have a social media post generator. So this example here uses multiple tools to provide an output. So what we're going to add, we can select which platform that we want to generate text from, and we have an example article here that we want to generate social media posts for. So let's go ahead and generate this social media post for Twitter. I guess I should rename that to X. So the first thing that it's going to do is you can see this going through several different phases here of creating the message. And then, I don't know, Danny, you can let me know what you think if this is going to be a very good social media post or not. Probably not. But this is what it comes up with, right? And so here's the process. It analyzes the article for key points, generates a draft, evaluates that draft for engagement, and if it thinks that the engagement score is less than a certain out of 10, if it's less than 5 out of 10, it will go back and call that previous tool and generate a different response until it thinks that the engagement score is at least 8 out of 10. It adds relevant hashtags, which is not really a thing anymore, and then finalizes the post with these improvements. And so we can see each step of the way what it's doing. So first, analyzing the article. And then I should probably work on the CSS for this, but this demo it still works, so we can read it. So here's generating that initial post. It's evaluating the post. It gives it a score of 8, so it continues on. It adds the hashtags, and then it generates that finalized post. So on the back end, what is happening here? On the front, we're using use chat. So really nothing different here on the front end, very basic stuff. And then here is the magic back here. On the back end, again, we're using tools. So we're just defining each one of these tools. Analyze article. This is a tool. We're telling it exactly what the parameters are and what it should do in the execution phase. We have our generate post tool. We have all the other tools are listed in here as well. And then create the data stream response. We're executing each of these tools. So here in our stream, we're passing it the tools, again, giving it a max step. We have a system message, etc. And then it just merges all of these into the data stream and returns them. So very, very simple. All of this, again, like just very few lines of code to do this. Otherwise would take 3 to 4x the amount of lines of code to do on your own without the Vercel AI SDK. So kind of wrapping things up here, we have some final thoughts here. So again, you can be an AI engineer. There's no PhD required. The Vercel AI SDK really does make things so much easier to implement in your JavaScript applications. And then just combining all of these patterns to make agentic applications. That is the future. Agentic applications, LLMs that can have access to various tools. That is the future. MCP, that's a new thing, Model Context Protocol. Building these things is where our applications are going. And so we really do need to get on board with those, learn these things, use tools that you have available to you, like the Vercel AI SDK, and give it a try and let us know what you think.